In this video, we will be reviewing how to use Logger Pro to perform a graphical analysis of data. So what I'll do is I'll run you through how to set up a plot in Logger Pro, and then we'll go through how to find the linear relationship between two variables. And once we just establish a linear test plot, we'll then go through how to write a mathematical relationship for the linearized data, and then finally write the relationship in words. So first I'll assume that you've done the reading. If you read the handout that I've given you in class called Experimental Design and Graphical Analysis of Data. And what I'm going to do now is going to skip to the last page, which summarizes the typical mathematical models that we'll see in this introductory physics course. So, as you can see at the very top row, we have a plot which yields a horizontal line. Whenever you end up with a experimental plot which has a horizontal line with a zero slope, that means that there is no relationship between your independent variable and your dependent variable. There's really no modification required because there's no relationship between the two variables. If you end up with a plot that is a linear relationship with a significant y-intercept, then in this case we call this a direct linear relationship between y and x. It's not a direct proportion, it's a direct linear relationship between the two variables. You could simply just say that y and x are linearly related to one another. If you end up with not only a straight line, but a line that goes to the origin, or at least 5% of whatever the maximum value is along your y-axis, then in this particular case, you could say that there is a direct proportional relationship between y and x. So you can say that y, whatever the y value is directly proportional to whatever the x is. And in some cases, you're going to see situations where the line is not a line really, and you have to manipulate it. And so you can see in the next graph here, we don't have something that is nonlinear, but it appears to be in the shape of a parabola that opens upwards. And so you can see here, to linearize this graph, we'll have to plot the square of the values on the horizontal axis. So whatever the independent variable is, square all those values and plot y versus the square of x. And if indeed y versus x squared produces a straight line, something like this or this, then you can then establish either a linear relationship between the variables or a direct proportional relationship between the two variables. And you would say, for example, in this situation, that y is directly proportional to the square of x. If you have in the next graph something where you have a parabola, but it opens up sideways, it looks like a square root function. So in this case, you're going to be plotting the square of the dependent variable, the vertical axis value. So you're going to square all these vertical axis values and plot that versus the horizontal axis values. And if indeed that plot yields a straight line, like this or this, then you once again can establish either a linear relationship or a direct proportional relationship between the two values of y and x. And lastly, you will see situations where as one thing increases, the other thing decreases. And here, what we would do is we take the independent variable, or the horizontal axis, we would take the inverse of that, or the reciprocal, 1 over x. And here we would plot the y value, the vertical axis values, versus the reciprocal of the horizontal axis values. And if indeed that produces a straight line, then you've established a inverse relationship between y and x. So now let's go on to proceed to plotting a sample set of data in Logger Pro. So in class, you were given the following worksheet on graphing practice, worksheet number 1, and I'm going to go through data set number 2 here. So what we're going to do now is we're going to put in our values along into Logger Pro. We're going to plot this graph. And then we can sketch the graph here. And then we're going to try to linearize the graph and show a sketch of our test plot, and then develop a mathematical expression, and then write it out in words. So I'll run you through this activity here now. So along the leftmost axis, or leftmost column here, I'm going to assume that this is our independent variable, which is going to be plotted along our horizontal axis of our graph. And then the one on the right here is our dependent variable position, and we're going to be plotting that along our vertical axis. Okay, I've started Logger Pro, and now I'm going to double click the header for the X or the dependent variable. So a little window should pop up that says manual column options. I'm going to replace the X with time, and then I'm going to change the short name here with T. That's the abbreviation we're assuming for time, and then the units will be S for seconds. Okay, and now it'll automatically change in here, and later on you'll see it changing in the graph. And then we're going to go change our dependent variable. And along our vertical axes, we're going to change that Y to be position. Okay, oops. And along the short name, we're just going to use simply X. And then the units are measured in meters. And I'll click on done. And sometimes I like to indicate that I'm actually using this as T for my variable for time. And then over here, I'm using X for position. Next, I can start to insert all of this data over into my data table. And all I do is simply just click into the cell and then type in the numbers, 0.03. You might even be able to copy and paste this as well. So go ahead and finish that. And you should see something like this. Now I'm just going to go and view our graph up more closely now. Now if you see something like I have, there's a little bit of an error. In physics, we do not connect the points. And this will happen by default if you have an older version of Logger Pro. If you click on the help and about Logger Pro and it shows a version, I have 3.8.7, I really need to update it by visiting the website and going to the version 3.9. But anyhow, I'll fix that now. So what I'm going to do here is I'm going to double click onto this white space here. I'm going to add a title in here. Remember, our title must be the dependent variable, which is on the y-axis, versus the x variable, the independent variable. So because the dependent variable is a function of the independent variable. So we're going to be plotting position versus time. All right, now, important here, I don't want these to be connecting the points. In fact, I can't even see the points. So I want to do two things here. I want to unclick the connect the points, so that box is empty, and I want to click on point symbol. So it should be set up like this. All right, so that if I click on done now, I can see now I have points visible. But then they don't really occupy the entire space of the graph. So to fix that, okay, I prefer, instead of using this auto scale button because it will auto scale larger, all of our graphs in physics will normally be having to have to show the origin here, 0, 0. So you really want, when you click on, double clicking on the white space and graph options, then click on the tab axes options, all right, and change this auto scale larger to auto scale from 0. And do that both for the y and the x, all right. And then you can click on done. If you wish, by the way, you could set your own manual values afterwards if you want. It's up to you. So I'm going to go auto scale from 0 and say done, and you can see now the points line up. And it looks like in this particular graph, it looks like we've got something that looks like a quadratic, right? It looks like a parabola that opens upwards. So we're trying to establish the relationship between the position and the time. And if you recall in our notes, when we have something that is facing an upward facing parabola, we need to square the independent variable values. So we're going to need to plot position versus the square of the time. Now you can go ahead and calculate that yourself, but I think, well, let's let Logger Pro do it. So I'm going to go now to data here, and we're going to click on new calculated column. We're going to calculate a column called time squared. So under the name here, type in time squared. And then under the short name, it's t squared. Don't do this. I see this all the time. It really annoys me. Logger Pro can actually do a superscript 2 for you. So you can put it to the power of 2. Simply go down to this little drop-down menu here with a little arrow here and click on superscript. It also does other things like Greek letters. Superscript and 2. And you can see that will become t squared. And then similarly for the units, you can do the same thing. It's not seconds, but it's seconds squared. That's a common mistake I see people doing, is forgetting to square the units as well. All right. Now, the last thing is you need to tell how to calculate it. You're doing time squared. So you click on variables, click on time, because we're going to take this and we're going to square all that. And to do square, you could do the caret and then 2, and that will automatically square all these values. So if I click on done here, it's going to create a column. You may not see all three. You could always stretch it out if you wish, like this. If you click on Command R, Control R, you will get auto range, and it will auto range it nicely in your window. Okay, that's under page and auto range if you wish. Okay, so you can see that we've got some kind of quadratic relationship here. And now we're going to be plotting now position versus time squared. So what I'm going to do is, just so I can show both graphs at the same time, I'm going to insert a graph. It'll automatically insert a graph. Unfortunately, it doesn't pick out the right axes right. I'll show you how to fix that in a second. I'm going to make sure it's nice and auto arrange for me. So I'm going to click on page and auto arrange, or Command R. And now I have a position versus time and then something weird over here. I gotta fix that. So on the vertical axis here, we really want position. So if you just click on that axis variable, you can then change to position. And let's change the time over here to time squared. Now you can't quite see it, I'm sorry, but that's time squared here. And now you can see there's a nice linear relationship in here. And so you can then test your idea by clicking on the linear fit button over here and seeing if the line goes through the points. And that's a pretty good correlation. It's 1.000. So that means those points all line up in a straight line. Okay, the closer that value is to 1, the better you are in terms of your data fitting right along the straight line. So I can firmly establish now that there is, my hunch was correct, that there is a direct relationship between position and the square of the time. So let's go back to our worksheet. Okay, we're over here on data set number 2, and now you can either sketch by hand your graph, or I'm just going to copy and paste this right in here. There's the graph that I had from Logger Pro. I just copied it over here. And so there's my position versus time. Looks like a quadratic relationship here. So the next bit here, I'm going to move down a little lower here on the page. So now the next thing we're going to do is going to show our test plot. Again, you can do this by hand. I'm just going to copy and paste this from Logger Pro over here. I'll just put that right on top. And so there's my graph of my position versus the square of the time. Okay, so we've established a linear relationship between position and the square of the time. So the next thing we're going to do is write the mathematical expression. So in Logger Pro has nicely put it down in the right variables for you here. So I'm going to use the same variables. Remember, we're using x here because that's what's going to be the symbol we use for position. We're not using y, by the way. And then we're using, for time squared, we're using t squared. So our mathematical expression is going to be x equals 3 meters per second squared. That's our units for our slope. I'm going to put this in brackets, by the way, because that's just the value that we're substituting in. And then multiplied by t squared. And there doesn't seem to be very significant slope. That's 10 to the power negative 15, so I'm just going to assume that's basically 0. And that's our mathematical expression. Last thing I would say is that make sure that you're able to describe it in words. And I've been saying it all along. The position is directly proportional, because it goes practically through the origin, the square of the time. In fact, it does go through the origin. And there's my statement written down in here. The position is directly proportional to the square of the time. And you very accurately have described the relationship shown on the graph. I'm going to stop here because the rest will you should try to do it on your own, and then we'll go over it in class.